Hey guys, welcome to Pre-Calc lesson 3.3. Today we're going to be sketching polynomial graphs. So as a warm-up here from Algebra 2, we're going to factor and sketch using the roots and the y-intercept of each of the following. So first thing I'd like you to do, factor this quickly, x minus 5, x plus 2. So what do we know? We know our roots, x equals 5 and negative 2. So that's going to be where it crosses the x-axis. The y-intercept is easy to get because it's what we get when we set x equal to 0. So basically this becomes a 0, that becomes a 0. There's my y-intercept. So the y-intercept, y equals negative 10. So we're just going to sketch that. We know it's quadratic, so that means a parabola. Leading coefficient's positive, so it's going to open up, and it crosses the x-axis at negative 2 and at 5. Crosses the y-axis at negative 10. So one thing to notice here, this is going to be important for the whole unit. This negative 10 is not the turning point, because notice the distance to that root and that root. It's not in the middle. So actually what's going to happen is the parabola is going to come down here past that and then turn around and go up. We're just sketching, so it doesn't have to be exact, but I don't want you to make that the turning point. Okay. Another one. Y equals 3x squared plus 7x plus 2. Again, what we're going to do first is let's factor that. A little bit more challenging to factor. It's got to be 3x and x. Signs are the same, right? Same, both positive. Okay, put those in. And our only factors of 2 are 2 and 1. So it's just going to be a question of where we're going to put those. We're adding the terms together. So I'm going to put the 2 here and the 1 here because I need to get a 6x and a 1x. That'll give me the 7. Okay, so my roots, it's going to be x equals negative 1/3 and x equals negative 2. And my y-intercept, which again is found right here. Why? Because we set x equal to 0, and what we're left with is a positive 2. So y equals 2. All right, so let's sketch this one. Both roots are negative. That's going to be a negative 2. That's going to be negative 1/3. And y-intercept is 2. So again, if you visualize what's going to happen, we have a positive quadratic, so opens up. It's got to go through these 3 points. So it's got to come down through like this, turn around somewhere between those 2 roots, and then head back the other way. Sort of like that. Okay, what I'd like you to do next is grab your graphing calculator. We're going to make a quick sketch of each of these functions. The first one, y equals 3x plus 2. All right, quick sketch of that. Linear, positive slope, y-intercept of 2. Looks roughly like that. Next one, I've got a quadratic, y equals 2x squared plus 3x minus 2. Most of you probably recognize that as a parabola. When you throw it into the calculator, you're going to notice you have one negative root, one positive root, and your y-intercept is negative. Looks like so. Next, we have y equals 2x cubed. You might remember that from last year and from our parent functions in Unit 1, but if not, you throw that into the calculator and you recognize you have a curve. It looks something like that, goes through the origin. And the last one is y equals 5x to the 4th. It looks like a parabola, but it flattens out at that root. It looks more of a U shape. All right, so what patterns do you notice? One of the things that I want you to recognize has to do with the degree of each one. So this actually has a degree of 1. And look at the end behavior. This is a degree of 2. Look at its end behavior. Degree of 3 and degree of 4. So you can probably recognize the pattern. If we have an odd degree, the tails, if you will, are in opposite directions. If we have an even degree, the tails are in the same direction. So that's kind of important to note. Odd degree, which is the greatest exponent, means your tails are opposite. Even degree means they're going to be the same. So how do you describe this? All right. We say as x approaches, let me use this notation, as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. That's a good math way to describe opposite tails, right? So as x goes to negative infinity, so as you go that way, y goes to negative infinity, we go that way. And then as x goes to positive infinity, y goes to positive infinity, we go that way. All right, so how about the other one? Even degree. As x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches positive infinity. So if you notice, y always goes to positive infinity. So that's why both of these goes to positive infinity. Okay, let's move on to types of graphs, positive and negative. Again, I'm hoping this is largely review, and I'm going to write the standard form of the equation and just make a quick sketch. So for linear positive, it's going to be y equals ax plus b. That's how you probably recognize on your calculator. Mx plus b, same thing. There's a simple sketch of one of those. Negative would be y equals negative ax plus b. And that would have a negative slope. All right, next our quadratic. Y equals ax squared plus bx plus c. So that one would open up. Negative would be y equals negative ax squared plus bx plus c. So the leading coefficient's negative, and that would open down. All right, we like to say happy if it's positive and sad if it's negative. Okay, next we have a cubic. So here we've got y equals ax cubed plus bx squared plus cx plus d. More terms. That'll kind of look like this. And a negative cubic would look something like y equals negative ax cubed plus bx squared plus cx plus d. And its end behavior would be opposite of the positive. And we'll go as far as a quartic, fourth degree. Y equals ax to the fourth plus bx cubed plus cx squared plus dx plus e. Fourth degree. It'll look something like that. And then the negative, y equals negative ax to the fourth plus bx cubed plus cx squared plus dx plus e. And that would look something like this. Sorry, a little sloppy there. But you get the idea. What I want you to notice, odd degree, opposite tails. Even degree, same tails. All right, so they're either going to be both up or both down. The general rule for positive odd is if you can flatten the curve and notice this general positive direction. So that even works here. If you notice these tails, the general direction is positive. This one here, the general direction is going to be negative, and that's how you determine it. All right, how are we going to sketch these? This is a little bit detailed here, so I really need you guys to pay attention. First, we're going to find the y-intercept. All right, now depending on how the equation is written, it's going to be the constant at the end. That's the easy way. Or if it's factored, it's going to be the product of the last terms. And remember, to get this, it's basically when x equals 0. So you can set x equal to 0, and whatever's left, there's your y-intercept. That's probably the easiest way to think of it. Okay, following that, we're going to find roots, which are also known as the X-intercepts. And we're either going to have to factor, hopefully, or if not, use the quadratic formula. All right, so that's actually going to be the easy part of this. Now we have to remember how to get the tails, or the end behavior. We're going to use I'm going to call them tails, rules. Remember, that's really the end behavior. All right, so here are the rules. If odd, so that means a first degree, third, fifth, etc. We won't have to go beyond that. We have opposite tails. All right, so now, if they're positive, they're going to look like this. If they're negative, they're going to look like this. So first we have to determine odd or even. If odd, positive or negative to get our end behavior. All right, if even, so obviously that's going to be the second, fourth, etc. We might have a sixth degree, but nothing more than that. We have the same tails. All right, so what's that going to look like? If positive, both up. If they're negative, both down. So that one's kind of easy. I think that's the easier of the two for sure. The odd ones we should kind of think about a little bit. All right, now let's sketch a few of these without a calculator. Sketch using roots and y-intercepts. Now, this one, if you notice, is already in factored form. So one of the things that I like to do is I like to get the first term and the last term, because that's going to make this problem a lot easier. The first term is found by taking the first term times the first term times the first term. So x times x times x is x cubed. It's going to be a positive x cubed. Then I'm going to have a bunch of stuff that I don't really care about. To find the last term, I take the product of the last terms in each factor. So 2 times negative 1 is negative 2 times 3 is negative 6. So now, again, I don't care what's in between, but this helps me with my graph. It's going to be an odd degree. It's a cubic, right? So and it's positive. It's a positive cubic, so I'm expecting something like this. This right away gives me the y-intercept because that's going to be the constant term on the end. So this is very easy to get now because the roots I can get from my factors, right? A negative 2, a positive 1, and a negative 3. So I can do that quickly. Here are my roots. X equals negative 2, 1, and negative 3. My y-intercept, y equals negative 6. What's left? End behavior. We sort of talked about already. It's a positive cubic, so my tails are going to look like that. I just need to sketch it. Sketching's easy. Don't rush it. My roots are negative 2, negative 3, and 1. So you can use tick marks here because those numbers are close enough together. Negative 1, negative 2, negative 3, and positive 1. That's fine. For y-intercept, I don't usually it's a bigger number, so I don't really put tick marks. I'll just make a note down here that that's negative 6. So you have to be careful when you do these graphs, right? It either has to be clearly labeled with the tick marks, or if you're just going to go out a certain amount of space and put a number, just make sure you label it. All right, so I'll definitely have to label that negative 6. All right, so now it's got to go through these points. It's got to go through a negative 3, a negative 2, positive 1, and my y-intercept is negative 6. So remember, the visual for a cubic, I was thinking this. So I have to make my graph match those points. All right, it takes a little while to get used to doing this. All right, it doesn't come easily, but that's why I need to sketch. All right, sketch that in. And we're done. Okay, let's move on. So now we're going to get into multiple roots. All right, so this one right here is not factored. I need to factor it. Well, if you notice, both of these terms have an x squared. So I'm going to factor an x squared out first. Let's do a little algebra. P of x equals negative x squared. And then what am I going to be left with? X minus 5. So notice it already has the negative out front. So I'm actually not factoring out a negative. I'm just factoring out the x squared from both of those. So now, what are my roots? Well, one of them is x equals 0, right? Because remember we said the GCF always will give you a 0. And the other one's going to be positive 5. But it's not that easy. Because if you notice here, this is a cubic. I only see 2 numbers. Well, I thought all cubics would have 3 roots. Well, they do have 3 roots. The thing is, one of these is a double root. Because this is squared, the root is 0, but it's called a double root. So we want to make note of that. The Y-intercept here is also going to be 0 because this is what's nice about it. When 0 is a root, the Y-intercept is always 0, right? If you think about it, it's got to go through the origin. Now, rules for sketching multiple roots. This is pretty easy. You might remember it from last year. If you have a double root, your graph will bounce. All right? And this turns out a double or any even root, really. So if it's like a fourth power, fourth degree root, it's going to bounce also. If you have a triple root, it passes through but flattens out. Now, the official math term is it changes concavity. That's the way it's curved. You don't really have to worry about that now. When we get into calculus, we will worry about that. That applies for like if you had a 5th degree root. All right, so let's make this sketch. Back to this example. I only have 2 points I have to worry about, 0 and 5. So instead of doing tick marks, I'll just put a mark out here and call it 5. So my graph goes through these 2 points, and that is it. One thing I kind of forgot about, I should do, I didn't mention the tails. We have a negative, odd, negative, odd. All right, so my tails are going to look like this because overall it's got to have a negative flow. So if we want to put tails in first, sometimes that's easier to get. It's going to bounce right here at 0. So it's got to come down. It's got to bounce on 0, go up, and then pass through 5. It's going to look like this. Okay, it's coming down here, turns around, goes up, and then back through, and continues on its way. Well, in this example here, it's already factored. All right, so one of the things that I want to take into consideration, what is the degree of this one? Well, I have an x cubed here, and I have an x times x there. So if I were to multiply all this stuff out, the first term would be x to the 5th. And then I have a bunch of stuff. My last term would actually be 2 squared, 4 times x would be 4x cubed. Not that we really need it in this case, and you'll see why in a second. So my roots, x equals 0. That's a triple root. Why is it a triple root? Because it comes from an x cubed. I also have a root of x equals 2, and that one is a double. And again, it's a double because notice this says squared. It's the same factor, and that's squared. Now, what's nice about this, since 0 is a root, it's also the y-intercept. What do you know about your tails? Well, you've got to look here. It's a positive, right? There's a positive in front of that, and it's x to the 5th. So positive odd means your tails look like this. All right, let's make a sketch. 0 and 2. So let's go through those 2 points. I'll use a different color. And my tails. Sometimes it's helpful to put the tails in first. Helps you visualize, all right? So At 0, remember, that's going to pass through. So it passes through, but it flattens out, changes concavity. Then at 2, the double, it's got to bounce and then go up. So it's going to look like that. All right, now let's sketch that in. So at 0 flattens out, passes through, goes up, turns around, bounces on the root 2, and then continues on its way. All right, let's try one that is not factored. We've got x to the 4th minus 5x squared plus 4. So I need to factor this. And at first glance, you're like, ooh, I don't know how to factor this because it doesn't have a GCF, and I'm not used to seeing this here. Well, I'll tell you right now, it factors exactly the same as if it was x squared minus 5x plus 4. So, okay, break it up. It's going to be x and x. Signs are the same, both negative, 4 and 1. Oh, it looks like that. The only difference is since it's x to the 4th, when you go to factor it, you're going to have an x squared and an x squared. Signs are the same, both negative. It's got to be 1 and 4. Now you can factor each one of these. Notice the difference between these two factors here and the way they're written and this one. This gets mixed up from time to time. This right here is basically saying x minus 2 times x minus 2. So it's already factored. These are not factored. They're the difference of two perfect squares. So I can take one more step here and write it down as x plus 1, x minus 1 times x plus 2 times x minus 2. So now let's get our roots. I've got x equals plus or minus 1 and plus or minus 2. Y-intercept, I'm going to get from the original. Look at that, right there's my y-intercept. All right, or you can take the product of all of these, in which case you get 4. So y equals 4, and tails, or end behavior. What do you notice? It's a positive even. So my tail is going to look like that, both up. Okay, quick sketch. I have positive 1 and negative 1 and negative 2, positive 2. There we go. Y-intercept is 4. I'm just going to put a mark up here and call that 4. And my graph has to go through all of these points. And my tails are both up. So now when you visualize, it's got to pass through. There's the intercept. It's going to look like this. That one has nice symmetry. They don't always have nice symmetry like that, but this one does. Pass through, turn around, and back up. All right, what do we got left here? Let's do 2 more. In example 5, we're adding something new. As you can see, we've got this leading coefficient. It's not going to impact our roots. We're still going to get our roots from those two. So for roots, I'm going to have x equals negative 1, and that's going to be a triple root, if you notice that exponent, right? Triple root. And then I'm also going to have x equals 4, and that's going to be a double root because that is squared. My y-intercept. This is where it gets a little tricky. For y-intercept, remember, we want to set x equal to 0, and whatever's left is the y-intercept. So if you set x equal to 0, what do we have left? Well, we're going to have y equals negative 1/8 times 1 cubed times negative 4 squared. So whatever you get when you multiply all this stuff out, that's going to be the y-intercept. All right, so 1 cubed is just 1. We don't have to worry about that. Negative 4 squared is 16. Negative 1/8 of 16 is negative 2. That's going to be my y-intercept. My tails. All right, we have to figure out what is this going to be if I multiplied everything out. It's going to be a negative x cubed times x squared. Well, if you were to multiply all of that stuff out, you'd have a negative 1/8 x to the 5th. So I've got a negative odd. Negative odd. Therefore, my tail is going to look like this. All right, let's make our sketch. I've got negative 1, and I've got 4. 1, 2, 3, 4. My y-intercept is negative 2. All right, so it's sort of this scale. It's going to go through these 3 points. And my tails It'll look like this. Now, triple root passes through. So at -1, it's going to pass through. And it has to, right? Because if you think about it, it's got to go through there and here. It has to pass through. Because if this bounces, then my y-intercept would be positive. So it's going to flatten out, pass through, continue below that, come up here. That's a double root, so it's got to bounce and then go back down. So that's kind of a visual of what this is going to look like. Try and sketch that in. Comes down here, flattens out, goes through this, turns around, bounces off that double root, and then continues on its way. All right, last one. So what I need to do here, first, I need to factor. All right, so p of x equals 0.5 or 1/2. This is going to be x. Signs are different, so probably -7, x plus 2. Let me just double check real quick. Yep. Now, roots. X equals 7 and a -2. The y-intercept. Remember, this is found by setting x equal to 0. 0, 0. So I've got this -14 and then half of that. So it's going to be 1/2 of -14, and it's going to be -7. Tails. What do we have here? We have a positive quadratic, so both up. And we just have to sketch. All right, -2. I'm just going to put a tick mark there, -2. Put a tick mark over here at 7. Y-intercept is -7, so down here. And this one's pretty straightforward. Quadratic, tails are both up. Again, I just want to point out, see how close this root is to my y-axis and how far this one is? This is not a turning point. It doesn't turn and then go way over here. It's actually going to go past that down below and then turn around. So when you sketch it, try and represent that. It's not the turning point. It goes down below it, turns around, then goes up through. Okay? Great. Thanks for hanging in there, guys. I know this was a long video. Don't hesitate to reach out, and thanks for watching.